In this video, we are going to discuss line integral, double integral, and triple integral applications. So with a line integral, we're integrating some function over some curve in 3D space. With a double integral, I have some function f of x comma y, and I'm integrating this over some region R in the xy plane, so it's two-dimensional. With a triple integral now, I'll have some function f of x comma y comma z, and I'm integrating it over some three-dimensional solid that I'm calling D. We saw that with a line integral, we motivated this by splitting up this region into a bunch of tiny pieces, each one with a length of delta s. And we did that to, we first did it to approximate the mass when we're given some density function. And that gave us this Riemann sum. And then when we took the limit where the length of each piece got closer and closer to zero, that defined this line integral. With a two-dimensional region R, we now needed a double sum, a double Riemann sum. And when we took the limit as the area of these small sub-pieces approached zero, that defined this double integral. With triple integrals, there's a similar sort of thing, except I would need a triple Riemann sum, and I would have to take the limit as the volume of these tiny pieces approach zero to define this triple integral. Okay, so what are some of the formulas that we have for these? So when I do an integral of just 1, so technically there's a 1 here, it gives us a measure of how big this thing is. So if it's a curve, that's arc length. If it's a double integral, and there's just 1 in here, it's a measure of this region, and that's going to be area. With the triple integral, if you do the triple integral of just 1, it gives you a measure of this three-dimensional object, which is going to be its volume. In fact, we've already seen that in our previous video. Okay, so we've seen before that when you take an integral of a density function, it gives you a mass. So when you have a curve, you do a line integral. When you have a two-dimensional region R, you do a double integral. And now if I have a three-dimensional solid object, I do a triple integral of the density function to get the mass. There's very similar formulas for the center of mass. Remember that if I want to get the x-coordinate of my center of mass, I'm going to need an integral, depending on what type of object I'm dealing with. So now I have a three-dimensional, I have a solid object D in 3D space. So I'm going to need to take a triple integral where I integrate x times the density function, rho of x comma y comma z. And then this whole thing gets divided by the mass being the triple integral of density. And then all that changes for the y and z coordinates is you change this x here either to a y or to a z. We have very similar formulas for the average value. So now if I'm doing the average value of a function over some three-dimensional object D, I take the triple integral of the function f of x comma y comma z. dv is my notation for triple integral. And then you divide that by the triple integral of just 1. And remember, that represents the volume of the object D. Okay, so when I have a line integral, to evaluate it, we parameterize the curve, and we substitute it. And we substitute in. When we have double or triple integrals, we do iterated integrals, do one integral at a time to evaluate it. With the double integral, there are two orders of integration. I can do dy first and then dx, or I can do dx and then dy. With the triple integral, there's a bunch more. Because if I do z first, well, I can do y after that, and then x. Or if I do z first, I could swap the x and y, so dx and then dy. I could put the y first, and then do dx dz, or put the y first, and then do dz dx. Finally, I can put dx first, and do dz dy, or dx first, and then dy dz. So overall, that's 6 possible orders of integration. So in the next video, we will take a look at an example where we use one of these applications. And in our remaining videos in the section, we'll practice recognizing, well, how do we know which order of integration is going to be best?